So today we're going to talk about 2021 Fall AMC 10B Problem 15. This is a really interesting problem and I got stuck on it. So in square ABCD, points P and Q lie on AD and AB, respectively. Segments BP and CQ intersect at right angles R. With BR equals 6 and PR equals 7, what is the area of the square? We have 5 options A, B, C, D, E. So we know that for the area of the square, all we have to do is find the side length, right? So we want either BC, AB, AD, or DC. So right now, let's just decide which one looks more achievable to find out. So it seems like that I have a right triangle here associated with BC, so let's just try to find BC. Okay, so at least we have a goal here. So our goal here is to find BC. So how do we find BC? So we're kind of stuck. We only have 2 side lengths. We have a bunch of 90 degree angles, but we don't know what to do because we don't have enough lengths for the Pythagorean theorem. So our goal here is we want to find so there are 2 right triangles here which we can use to find BC. So one is CRB. Another one is CQB. So now which one looks more achievable this time? So we want to find the side lengths. So it seems like CRB looks more achievable because we already have 1 length. So RB is already 6. So all we have to do is find CR. Okay, so our goal here is going to be find CR. So we want to find CR. So how do we do that? Well, we can use similar or congruent triangles. So firstly, I want to prove a few congruent triangles. So pause the video and try and find congruent triangles. So assuming you pause the video, now let's look at the congruent triangles we do have. So there aren't much triangles, so it should be easy if you just highlight every triangle and compare them in size. So we will figure out that triangle PAB is congruent to triangle QBC. So let me just write that down. So triangle PAB is congruent to triangle QBC. So what does that tell us, and why is it congruent? So firstly, we need to know why this is congruent, so let's say I call this angle here alpha. So that's my angle of alpha. So I know a lot of 90 degree angles inside right triangles, so I can use that to figure out other angles in terms of alpha. So this is 90 degrees. So I have RQB is equal to 90 degrees minus alpha. Because if you sum all 3 angles in a triangle, they have to be 180. So this here is just 90 degrees minus alpha. And I also know that this is a right triangle because this is part of a square, so that's a right angle. So my angle here is also 90 degrees minus alpha. So now we also have, so we know that this angle here is also 90 degrees minus alpha. And we know angle CRB is 90 degrees. So angle QCB is alpha. So if you can see this clearly, we have, so in our triangles CQB and PAB, we have angles, so we have this angle equals to this angle, so angle Q is equal to angle P. We have angle B is equal to angle C, and we also have a side length because so our side length here is AB is equal to BC. Despite we don't know the length of these sides, we know that they're equal because AB and BC are both side lengths of the same square. So we can prove by angle-side theorem that we have PAB is congruent to triangle QBC. So what does that give us? So luckily we know that PB, so we know that PB is equal to 13 because PR is 7 and RB is 6. 7 plus 6 is 13. And we know that from the congruence, we know that PB is equal to QC. So that looks kind of obvious, but now we've just proved it. So PB is equal to QC. So QC is 13 also. So okay, at least we have something else now. QC is 13. That's another clue. So I have QC is 13. Now I want to figure out RC. So what about if I let RC equals X? Because I'm going to use RC a lot. So I'll just make it more easier to write RC. So I'll just let RC be X. So my QR is going to be 13 minus X. So now I have a couple of Pythagorean theorem things to do. So I know that here I have 13 minus x squared plus 6 squared is equal to bq squared. I also know that x squared plus 6 squared is equal to bc squared. I also know that bc squared plus qb squared is equal to 13 squared. However, there's a way simpler method than approaching the variables with the Pythagorean theorem, which is proving similar triangles. So if you don't notice, I'll just highlight this in blue. We have inside triangle QCB, so triangle QCB is a right triangle, right? And BR is actually perpendicular to CQ. So we have two right triangles inside the larger right triangle. So these two right triangles are similar to each other and also to our larger right triangle. So how do we prove that? So we know that the angles are equal. So firstly we have this angle here, so is 90 degrees minus alpha for both triangle RQB and triangle CQB. So that's one angle equal. And for similar triangles, we want two angles equal. So we have alpha here for RBQ, and we have alpha here for QCB. So we know that triangle QRB is similar to triangle, so QRB is similar to triangle QBC. With the same theory, we can prove that triangle BRC is similar to triangle QBC. So now we have three similar triangles. So we can use the proportion between the side lengths to figure out x. So how do we do that? So x is inside triangle CRB, and it's the longer leg. So we have x over another longer leg, so we could use the other longer leg, which is BC, or actually we should use 6 because we know 6. So 6 is the longer leg of triangle BRQ. So x over 6 is going to be equal to something else. So let's use the shorter legs this time, because 13 minus x is the shorter leg. So, and the shorter leg for triangle CRB is just RB. So RB is a shorter leg, right? So we have shorter leg over shorter leg is equal. So that's equal to 6 over 13 minus x. So we have an equation with only one variable in it. So that's great. We can just solve this equation. That's simple. So if I just solved it, I'm just going to skip the solving process here. So I can just factor this out, which gives me x minus 4 times x minus 9 is equal to 0. So that's my result. So if I just solve this, I have x is either 4 or 9. So here I know that RC in the graph looks like it's longer. So I'm just going to assume that x is equal to 9, and 13 minus x is going to be equal to 4. So now we've already finished one of our goals. So this one's a check. CR is equal to 9. So we can use the Pythagorean theorem here because we have CR and BR. So we can figure out BC. So BC squared is equal to, root 9 squared, which is 81, plus 6 squared, which is 36. So that just gives me, so actually I want BC squared because that's my area of my triangle, of my square, right? My side length squared is the area of my square. So I want BC squared. So BC squared here is just going to be 9 squared, which is 81, plus 6 squared, which is 36. So that just gives me So 117. So my answer is D, 117. So I just circle that and I'm done with this problem. So the key point in this problem is to realize that we don't have much sides, but we have a lot of 90 degrees angles. So we try to find similarity and congruence using the angles we've got. And we can also use Pythagorean theorem and also similar triangles to list out equations and solve them. So thank you for watching.